In this video, we're going to take a look at how we solve one-step inequalities. What's important to realize in solving one-step inequalities is that the process for solving these inequalities is going to be the same exact process as solving regular equations, with one exception. So, if I have something like x plus 6 is going to be less than 10, I'm going to subtract 6 from each side. I'm going to treat kind of the inequality as being the divide, like the equal sign. The 6's will cancel out. I get x is going to be less than 4. So if I go ahead and graph my solutions, I'm going to get an open circle on 4, and it's going to be all the values that are less than 4. So if I think and try one of these solutions, for example 2. 2 plus 6, is that going to be less than 10? 8 is less than 10, so it checks. So I've shaded in the right section here, okay, in the right direction. Subtraction works the same way. If x plus 6 is going to be greater than or equal to 10, I'm going to subtract 6 from both sides. I'm sorry, let's change that to x minus 6, I meant. So I'm going to add 6 to both sides. The 6's will cancel. I get x is going to be greater than or equal to 16. So values like 17, 17 minus 6 is 11, 11 is greater than or equal to 10. So that holds true. So for addition, subtraction, inequalities solves the same way as just equations. For multiplication and division, the rules pretty much hold with one exception. If I have a normal sort of inequality, 3x is less than 9, I'm going to divide by 3, x is going to be less than 3. So if I check this, a value less than 3 might be 2. 3 times 2 is going to be less than 9. That checks. If I have 3x is less than negative 9, same thing, divide by 3, x is going to be less than negative 3. So a value less than negative 3, negative 4. 3 times negative 4 is going to be negative 12. Negative 12 is less than negative 9, so this checks. The exception comes when the coefficient on the x is negative. If I deal with the negative 3x is less than 9, if I try to divide by negative 3, I get x and negative 3. If I keep the inequality as less than negative 3, an example would be negative 4 would be a value less than negative 3. Negative 3 times negative 4 would give me positive 12. And if I ask that it's less than 9, it's actually greater than 9. So this is not going to be a solution. So what I need to do is anytime I multiply or divide by a negative value, I'm going to need to flip the inequality sign. So it goes from less than to greater than. And if I pick a value bigger than negative 3, let's say 0, negative 3 times 0 is going to be 0, which is less than 9. So that checks now. Okay? So this occurs anytime I'm going to multiply or divide by a negative. I'm going to need to flip the inequality. Okay, so this is what we're going to practice with a little bit the next couple days.